Hello, guys, and welcome to the new Tech Talk series on the channel. This is a segment that was inspired by a colleague of mine, so I hope you're watching, buddy. Now, in this series, I will be focusing on providing engineering talks on topics in the tech industry, predominantly software engineering topics, maybe some DevOps, and anything else that tickles my fancy, really. So we'll see what happens. Now, in this video, the topic of discussion is advanced Python unit testing and how you can go about implementing the testing techniques into your own Python project. Now, my presumption is you're already in tech and familiar with the Python programming language, or perhaps you're new to tech and you're currently learning Python. Either way, this engineering talk is going to be valuable to you and provide you with knowledge to develop a new skill set. So let's not waste any more time and get into it. All right, so the structure of the presentation is as follows. I'm going to introduce the general unit testing or software testing topic briefly and speak a little bit about the development processes that use testing, or some of them, and then go straight into showing some code snippets and the unit testing around them, essentially. Okay, so let's begin. So software testing, what is it? So software testing as a whole kind of topic is essentially a method to perform what I regard to be an audit check on a software product. And the reason for this is to make sure that the software product satisfies the expected requirements by customers, business, and whoever else is involved, any other stakeholders. Unit testing, testing as a whole is also there to ensure that the software product itself has no defects, or if there are any defects, they are identified and resolved as early as possible. Now, this is important because, well, if there are any errors, we ideally don't want customers to be the ones that tell us about errors or bugs or anything like that. We want to know ahead of time so we can fix them, and then clients just get a good user experience where everything just flows. Now, that's not to say in the history of software development, every product that's been put on the market doesn't have bugs, but it's never a good thing if customers are the ones telling you, or users are the ones telling you, your software is broken in these areas, right? It's one of those things, but it happens. It is what it is. So quickly kind of glancing on the benefits of this thing. One of them is it's cost effective in the sense that if you do the unit testing as you build the product, you can identify any new errors or changes in features and whatnot early and fix them, address them ahead of time. And this is cheaper than building the entire product, releasing it, and then discovering half of your happy parts, if you will, half of your features have bugs, and then now you have to go and fix them all, but you have the added pressure of the customer is waiting, there's a shorter deadline, and generally the customer is also unhappy now. Potentially your own business is unhappy because the whole business looks bad, right? So there's all those kind of added layers. So it's more cost effective to just do this as early as possible. There's a term for it, I can't remember now, where you fail fast. There you go. It's like it's better to fail fast than to fail slow, in the sense that the quicker you hit the roadblocks and you fix them, the better. Just get them out of the way. So it's like front loading that shit, basically. Security is another added benefit, because any vulnerabilities that are caught ahead of time, it's better for the product in terms of trust. Like users just trust it more because they just know the product works. Because if we're being honest, I believe we've all used
software products, and we don't really care about the back end of the product. We just want it to work for whatever we're doing, using it for. Otherwise, it's frustrating if we have to start telling the developer what's wrong with their product. Like, we should have solved this, right? I know I feel this way about Microsoft products all the time, but I digress. I don't want to shit on Microsoft too much. And the other thing is, the less bugs or that a software product has, the more quality the product is, right? It just works. As I've illustrated before, it just works. Another thing I wanted to add, it's not really a benefit or anything, it's more generally about software testing, that this is more my thing, which is I look at software testing as the cornerstone of software development, in the sense that this is your way of knowing the product still works. So, or for not just you, the developer, but other developers. So I'll give an example. If I was working on, I don't know, context matching or something within the 4D platform, and I'm coming in with the context matching features already in place, right? If I start making changes as required, like as requested for like improvements or changing direction or whatever it may be, I'm happier knowing that there are tests that currently test the entire behavior of the product, of the context matching feature as it is, so that when I change stuff and then run the test will tell me what I've broken or what I've changed that now breaks the test, so that we know that, okay, I just need to fix these here. I just need to either add new tests or change the tests that are in place to account for the new behavior, essentially. It also means that I'm fairly sure that if I've broken it, I'll know before I release the product, right? And then it's less embarrassing. So that's just my kind of the way I look at it. I just look at it as a cornerstone of the whole thing. But yeah, moving forward. So the next thing is, we're going to talk about some software development processes. Now, on screen, I only have 2 of them because these are the only 2 that personally I think matter. There's a bunch of others, but they don't really matter. To be fair, even on screen, there's only one that matters, but that's just my personal opinion. So BDD, which is behavioral driven development, and TDD, which is test driven development. 2 approaches which heavily, depends on what, heavily align with putting tests into a software product as you develop it. And they share common elements, as you probably can see on the screen. But their major differences are behavioral driven development is a process that's more oriented towards meeting the business requirements. Whereas TDD is like a development technique that focuses more on writing tests. So with TDD, it's write the test first, and it's going to fail because there's no code to test, obviously. And then you write the feature afterwards, and then you try to make the feature pass the test, essentially, which I think honestly is dumb, because half the time, I think we're going to all agree, when you're writing new features or even changing features, you don't really know what the final feature looks like, what the final outcome of the feature looks like. So you can't really write tests for things you don't know what they look like. What are you testing, right? I think when TDD was kind of put into place many moons ago, more like millennia ago by now, it was more for simpler software products where you could easily predict how a feature is going to look. Whereas nowadays, software products are more complex. You're communicating with S3, other APIs, I don't know, half the world or some crap. So it's like you can't really write a test for a feature until you've actually written the feature, because now you know what you're trying to put tests for, essentially. And also, TDD runs into the danger of testing the code instead of testing the actual feature and what it's supposed to do. That's one of the dangers because of its focus on writing tests. You end up just trying to test the code, not what it's supposed to do. Now, BDD, which is my personal favorite, you probably could tell because I've just, slacked off TDD a lot there. Is the name states, it's more about the behavior of the product, right? So irregardless of how the code looks, what you're really testing for, or what you're really doing there, is you're taking a business process or business requirement and implementing it, and then saying, with the test, is the expected behavior being performed by this new feature or this new code I've put in place? And that's better because you don't necessarily have to test, sorry, just notifications coming up here. You don't necessarily have to test all of the code, you just have to test the behavior, essentially. You don't really care about how the code is laid out. Does it meet the behavior? And the behavior can be success parts and failure parts. And what I mean by that is the feature, I'm trying to find a simple feature.
In the original engineering talk, I presented this to my colleagues. So the example I gave for BDD was related to a feature within the flagship product of the company I work for, which I don't think is a good idea given I'm going to be posting this on YouTube. So instead, I will provide you guys with a different feature just to explain BDD and how it would go about testing the behavior of said feature. And in this case, we're going to talk about a login page or a login capability for an application. So when you're testing the behavior of a login feature, you have two scenarios. The first one is, if I supply the correct credentials to this login facility, I get authenticated and I'm allowed into the application, and I end up landing on some sort of dashboard. And option two is, I supply incorrect credentials and the application doesn't allow me to authenticate, but instead presents me with an error message. And with BDD, the two tests you'd write would test that with correct credentials, you end up on a dashboard, and with incorrect or bad credentials, you don't get authenticated, you stay on the same page, but you have an error message presented to you. That would be the test in that case, in terms of behavior. Anyway, let's get back to the rest of the engineering talk.
We test for all these scenarios, basically, and that's all the behavior we're testing for, those scenarios. So personally, I like it better because of that. It's less looking at the code and more the behavior. Now that I've finished championing BDD, we're going to move on. So essentially, this is the last of the shiny, nice slideshows. Up next, we'll be looking at some code snippets and then kind of go through some different kind of functions and how to test them, essentially. Okay, so let's do this. So on screen now is I'm calling it a basic test. And honestly, I don't expect to spend too much time here because I honestly don't want to teach anyone to suck eggs, as it were. I think that's the right expression. But as you can see on screen, I don't know if you can see my mouse. Can you see my mouse?
Yes.
Okay, excellent. This makes it easier. So we have a function for adding two numbers, right? Simple enough function. And it's functions like this where TDD would have worked, obviously, because it's simple enough. You could kind of see this in your mind. And we have two tests on the right-hand side. So the first test is testing a successful result of the behavior. And the behavior we expect is we give you two numbers, the function adds them, and we get a certain result, which is what we do here. And another behavior we can test for is a failure where, what if someone who's not us, some other random person was to come in and go, I'm going to test how I don't know, how agile or broken this code is, and just provide a string instead of a number for one of the parameters. We expect that the code or the function would return a old razor type error in that test. That's what that test checks for, essentially. So if we were to then move forward and, for example, put a check in that add function for for handling a try and a type error, for example, before we do the adding, then the second test would now fail because the type error would never be raised because it's handled. So if we were to change this code, the failure one all of a sudden is now broken, because then we'd have to account for, maybe we return a nice message. So that might be what we now have to look for as a result, is a nice message being returned instead of the number. For example, saying, I don't know, hello is not a number. Please provide a proper number or something, a proper int or something. So those are a few behaviors that you can account for. And this is simple enough. So yeah, all right, moving forward to the fun stuff. So I'm going to jump straight into mocking in tests, and kind of just, because you're probably thinking, well, that was, a bit of a jarring move from basic test to mocking. And the reason is, most of our tests in the Avocado apps or the microservices, because they're all mostly Python applications, there's a lot of mocking involved, or at least a mocking that needs to be involved, because we're always communicating with S3, DynamoDB, I don't know, Reticle, Xander, something else I've never heard of. There's a bunch of things, or machine learning packages, APIs, you name it, right? We're communicating with a bunch of things. So mocking essentially exists within the Python framework. I'll just get this out of the way. I don't know enough about the history of mocking, because the truth is I don't care. I just care about using it and that it works. So yeah, mocking exists in the Python framework whenever it was put in place. I'm sure it was put in place in Python 3. I would be surprised if it's a Python 2 thing. But it exists essentially to, first of all, prevent your tests from communicating with outside APIs like S3, Boto, you name it, because the last thing we want is for our tests, which run regularly on pretty much every branch, every feature, etc., to start communicating with Boto 3, because one, we could end up either retrieving real data and using it for testing, or which is a security problem, or we could end up posting data to S3, for example, or another API that's test data, and end up marking the production data in that API, like Xander or Reticle or whatever, for example. So mocking is there to prevent that, whilst at the same time mimicking the same behavior that Boto would have performed, or S3 in this case would have performed, if it was really cold, if you will. So this is a simple enough function on the left. On the left, it's just a connection to S3. And the way to test that is, you can just, it's called patching, which is just mocking essentially. You just patch Boto 3, and the module is the location of this function, whichever file it's in, whichever Python file it's in, is what you'd put where it says module. And then just inject Boto 3 afterwards, so that it knows what is mocking in that module. And then you just need to provide a parameter that you can use in the test. And then essentially this line, what it's doing is, so one thing I should mention is, anytime there's some sort of function, like the client, which is a function, any function like this is expected to return a value. The value could be none, or it could be something else. That's the expectation. So what we could do, if we want to get to the S3 client, so that we can do some extra testing with that or extra mocking with that in our test, is we can just tell the mock of Boto 3 to get the client, which is this client, and then return the value, which is the value of whatever this would have returned, essentially, the connection itself. And then, which would be the client that it returns, right? And then when we actually do the test on S3, what it does is it injects this mock as part of when it runs this. So when it actually calls Boto 3, it's calling the mock, not the real Boto 3, essentially. And essentially injecting this under the mock. And then the last thing is this assertion. So what we're doing here is we're making sure that our mocked S3 client was called with the parameters we expected. So in this case, we'd have some development or testing secrets that we'd have. And we can easily check to see if what we expected to be put in place is what's put in place here, essentially. because you can actually mock, because all these secrets come from like settings, right? From like a settings file or the environment. So you can mock the environment, you can mock the settings file, you can mock pretty much anything you want. And you can easily tell the test that the environment that has been mocked and endpoint will be equals to this value, basically. And then you can just plug those values in here. I didn't do that because that would be quite a long test, and it actually didn't fit on screen, so I had to shorten it up a bit. But essentially, that's what this does. Now, one thing I will say is you don't always need to do this kind of assertion where you're checking to see what a mock has been called with. And the reason is sometimes some APIs or functions that are mocked are quite complex. So sometimes you just want to do like you just want to do like assert code once, or just assert code if it's in a loop, and you can ignore the once with, for example, because all you care for is to make sure that the assert was called, which means the code went through that piece of the branch of the feature, basically. And you just know at least the S3 was invoked, even though it's mocked, as part of the test, essentially, which is good enough for satisfying the test and the behavior. Because all you care for is, if we were to call S3 connection, will boto3 be called? Will an S3 client be returned or invoked at some point? Yep, the test kind of satisfies that. We're good. And that's essentially that in a nutshell. I'm hoping I explained that really well, but we'll find out at the end of the presentation. So moving forward, we have more mocking. This one is a bit more complex. So I've just taken the same S3 connection function from the previous slide, essentially, but this time I've added an added dimension, which is we're getting the connection and then we're actually pulling something from S3 and loading it via JSON loads and everything, right? That's what this channels from S3 function does. It just connects to S3 and grabs a channels JSON from a location and then loads that back into the memory for Python. Now, to test this, there's two things we need to test. One, there's two things we need to mock, sorry, I should say. There's two things we need to mock. The first thing is the S3 connection, because now we don't need to mock the boto, we just mock the actual S3 connection function as a whole, because it's just simpler, right? Because imagine that S3 connection was an imported function. It's not in the same file as this function. So if we import S3 connection, we can just mock S3 connection. Alternatively, even if S3 connection was in the same file as the channels from S3 function, you can still just mock S3 function. You don't have to mock boto3. It's just you're just removing edit layers that are necessary. So yeah, we just straight up mock S3 connection, and we also mock JSON. The reason for that is we know JSON is going to be called to return some form of JSON from S3. So we want to mock that so that one, this could fail because as of now, client get object is going to be a mock. So if we were to provide a mock to JSON loads, it would just throw an error. I think it'd be like what is it? JSON loads error or something like that. I can't remember, some sort of validation error. So we will need to mock that ourselves to ensure that we don't get any weird errors that are necessary, because we know JSON loads will be called at some point, and we can just tell it what to return. So that's two things. So another reason I put this kind of scenario in place is, so because there's two things we have to mock, right? There's an ordering that matters, right? Because when you're mocking, you mock in the order functions or classes, whatever it may be, are called within a function, essentially. You don't just mock them in a mumbo jumbo way. It's ideal, you can, and it works, but it's ideal to mock them, to set the mocks in the right order. So we have S3 connection being called first and then JSON loads. So, and this is where it's going to be counterintuitive. So S3 connection, as you can see, is below JSON, and that's because when you're doing patches for any mocks. Anyway, So where was I? Yes, so this is where it's counterintuitive. So the patches are, as you can tell, JSON is on top of S3. And the reason is the mocks, when you're putting the mocks in order, you're putting them going upwards. So you're saying this gets called first, S3, and then JSON gets called second. So it goes up. So whatever is the highest mock on a function in terms of patches is the last thing that's going to be called. Or that's the last thing that's expected to be called within the order of those patches, essentially, of those mocks, sorry. That's the idea. However, conversely, on the parameter side, they're in the order where in this normal order. So yeah, it can be a bit of a what the hell moment. I don't know why they did it this way. That's the truth. I've been asking this question to myself for years. I don't get it. But essentially, this is the way they're ordered in the parameters, and they go upwards in terms of order in the mocks that are patched. Yeah. So in terms of the ordering, the S3 would match to this because it would be like, oh, the first parameter here matches the first mock, and then that's how it works. So if you were to make these a different order, that means the parameters here would have to match whatever order you have here. Otherwise, you'd end up setting return values to the wrong mock, essentially, which could be a problem and actually cause the test to fail, because if it's expecting JSON data and you say, oh, but I'm returning you something else because the mock is different. For example, if you had said, if we're DynamoDB instead, and we jump on S3 connection with DynamoDB in the ordering, you could end up returning what should be an S3 connection JSON object as DynamoDB, and then the code would fail and you'd be perplexed as to why that's happening in your test anyway. So the next thing is you just set some return values. And as you can see, I literally provide a proper return value for the JSON loads because I already know client get object will return some form of JSON object essentially. So I'm just telling JSON loads what it's going to return because JSON loads is a function. So I just kind of wrapped it all together. And then we called the channels from S3. Now I put result here, but I don't think it was needed because then I can't assert what the result is. Actually, no, I could. The assertion would just be, does it match this? Which it would, because I've given it the result myself. But you could still make that assertion to make sure result is equals to whatever the mock of JSON loads returns. And then the next thing is to make sure that the connection was called once. And assert code once just means, is it called literally once, basically? And that's what it checks. I could remove the once and just say assert code and it will still work. Once is just more specific because assert code just implies it was called, but it could have been called like 50 times in a loop or something. That's the only difference. And then as you notice, I only, for the mock JSON loads, I only said assert code once, but I didn't put the width to see what the parameters were because the parameter is a client object, etc., etc. I didn't want the hassle, so it's enough just to make sure JSON loads gets called essentially. And then I even went further and even checked that the get object was called as well, which is this, and that it was called with the expected parameters, which was some sort of bucket name and a key, which in this case, I would have potentially mocked the bucket name from the settings and the key would be this. So cluster would also be mocked as to set some value. So I could easily check that. So that's essentially mocking in this way. Now, the good news is this is only one way of mocking, and this is a way of mocking which requires ordering. There's another way of mocking that doesn't require ordering that I'll touch upon in the next few slides. The mocking side effects. So remember when I spoke earlier, I mentioned that when you're testing behavior within a feature or function, you can also test for failures, for kind of either expected failures or possible failures. So if you're testing for these failures, like error handling, errors being raised, but you're dealing with an S3 connection, for example, you can't like cause the S3 connection to give you an error like manually because you're mocking it. So you're gonna have to give it what's called a side effect. And the side effect essentially is you telling the mock you're going to raise an error, and this is the error you're going to raise, essentially. That's what you're telling it. Or you could give it some other. The side effect could also be an error message. It's whatever you want it to be, but usually it's in some sort of exception. So in this example, it's the same function, channels from S3, that we were testing before. But now we do the same mocking as normal. But now we don't provide any return values. We just tell the test ahead of time. The S3 connection is going to have a side effect of client error, which is a legitimate Boto3 error that's raised if you fail to connect to the S3 client, basically, via in Python. And so our actual test is to make sure that when we call channels from S3, what? Oh, no way. Okay. Sorry. No, the other way. I got distracted. My mic is doing weird stuff on its own, but mind of its own. It's as if Skynet is already in place. But yeah, the idea is if channels from S3 is called, we expect in this test that a client error exception is going to be raised. And so that's what we're testing for, the failure in this case. And we also can go on to test even further, do the asserts on the mocks to make sure that the S3 connection was called, because that has to be called for the client error to kind of be raised. Excellent. But the JSON loads wasn't called, and neither was the S3 client get object, because once the error was raised, it stopped right here. The rest never got called. So that could be the added layers of your test to make sure that the error is raised, and also certain mocks that should have been called wouldn't have been called as expected, essentially. So this is just another kind of layer to the mocking that's also in place. And so, yeah, that's pretty much it. I don't really have much more to say about this. It was a quick one. And so earlier I mentioned, or in part one, I mentioned that there is a mechanism by which you don't have to worry about ordering the mocks like you have to order them with the parameters and everything. There is a way to do it, but it only can be done in specific cases. And this is where you can do for a testing class, you can mock an object at a test class level, so that every test in that test case deals with the object as a mock. And that's what we have here. So we're keeping the same function channels from S3, but now we are patching it in the setup and not at the test function level. We're doing it in the setup. And that means if we have 200 tests in this test case, all of them are going to be, this is going to be mocked for all of them. S3 connection will be mocked for all of them. And now the ordering doesn't matter, because we've just invoked S3, self-mock S3 if you want to do anything with it. That's what we need to do. And where this works, because this only works in specific cases, is when S3 connection is being like called by a bunch of functions in a module, basically, right? Because if only channels from S3 was calling it, then it would make no. I mean, it would still be ideal to just mock it here in the test class, in the setup, because it makes it easier. But at times there's no point, because only one function actually needs the mock, if you will, or one function is using S3. So why mock it for everything? So that's when you do the patching like we did before at a test function level. But if, for example, 3 or 4 functions are using S3 connection as part of their whatever they're doing, then just putting in the setup I is the best way to do it. And this piece of code does it. It's essentially the same thing, except without the special S function decorator. You're patching the same S3 connection via the module, and then you have to tell the patcher to start whenever setup is run, and then you have to clean it up at the end when like all the tests are being teared down, basically, or the test is being teared down. It has to clean up after itself. So if you put it inside the setup function, it's called for every single test that's run, for every test function that's run. So it will remock every time, because the setup function is run for every test. essentially. Conversely, you could also put it in the class method, set up test data, where it's kind of where it's mocked once, it's run once, and then it's never redone again. However, here are the limitations. If you put it in the setup test data class method, then you can never do the assert code once with. You can never do the with part where you can check parameters, because it's never going to be teared down for the next test. So it's going to be called with a bunch of different parameters all the different times, possibly, potentially. So, because each other function that's running the S3 client might be using different buckets. So you could have 4 functions using 4 different buckets. But because you've only mocked it once, it's never teared down at the end of the test. You can't do the assert with, which sometimes is convenient enough if you don't care about that. But if you do care about going the extra mile of checking to make sure that the right mocked functions are called with the right parameters, you'd have to put it inside the setup method, because that way it's teared down at the end of every test and kind of re-mocked. So it just works out. But essentially, the rest of the rules around mocking remain the same. This is just kind of an added layer of abstraction for the mocking, but everything else still works the same way, except now you're invoking a class level object, a mocked object, instead of just a function level decorated mock, essentially. Yeah, so yeah, you could easily do the same thing for JSON, for the JSON loads as well, in the setup function, in the setup method, sorry. Same rules. It's just you're just mocking it, so you could do the same thing, just as a separate kind of set of 3 lines for JSON patcher, mock JSON, etc. So the same rules apply. It's just I didn't have the space to put the JSON one in there. Actually, this is the end of the presentation in terms of testing, and now you guys can fire away the questions.
Thank you for watching this video. I will catch you in the next one. Signing out.